Today we'll talk about circles, inshallah, with the 5 questions, same thing, okay? This is one of the major and main topics, okay, in geometry. So let's see, start with the first question. A square of area 2 is inscribed inside a circle. So what is the area of the circle? Check this with me, guys. This is a circle and this is a square, okay, approximately it's inscribed inside it. And the question is giving me such information like the area is 2 of the square. So which means the area is equal to 2 and this is equal to side square. So in this case, 2 is equal to side square. So the side of the square is equal to how much? Square of 2. So this is the side of the square. Square of 2. And this is square root of 2. Okay, fine. So fine, what's the area of the circle? If you want to find the area of the circle, you need to find the diameter and the radius of the circle. So in this case, if we do a diagonal here, we have this is 90 degrees, you can see here, there. So we have square root of 2, square root of 2, and legs, 2 legs, and there is a 90 degrees, so we can use Pythagorean theorem. So if I can say, we call it x, so it's x is equal to radical, okay, radical 2 square plus radical 2 square, and that's equal to how much? Radical 2 plus 2, which is the square root of 4, that's equal to how much? To 2. So in this case, the diameter of the circle is equal to 4, okay? Sorry, 2, after we do square root. So the diameter is equal to 2, so in this case, the radius is equal to 1. So r is equal to 1, as you can see here. Fine, after that, we can say in this case, so the area of the circle is equal to pi r square, which means pi times 1 square, and that is equal to how much? Pi. Okay? Same question 2. Okay, here question 2. Check this question. If A is the area and C is the circumference of the circle, which of the following is an expression for C in terms of A? Okay? If A is the area and C is the circumference, which of the following is the expression for C in terms of A? Okay, so I have 2 expressions. So I know that C is equal to 2 pi r and the area is equal to pi r squared. So actually what I want, C in terms of A. So I need to remove r and put something which relates to A. So check this one. So the area is equal to pi r squared. I can say r squared is equal area over pi, and r is the square of area over pi. Okay? So r squared is equal to area over pi. Okay, and in this case also r is square root of area over pi. Can I replace the r here with this one? Of course, yes, I can do that. So C is equal to 2 pi times radical A over pi. Okay? This is one way of exchanging. I can also work out the r is equal to C over 2 pi, but since we start with this, okay, rule, okay, we can go with the other one, no problem. So C is equal to 2 pi. I can square both sides, so that's going to be equal. In this case, check. C square is equal to 4 pi square A over pi. Why? I just squared this, squared this, squared this to remove the square root, okay? So in this case, that's the solution. Of course, the square goes with the pi, okay, here. Fine, so for pi, A, C squared. So after that, C squared all over 4 pi is equal to what? To A. Okay, there wants the C in terms of A, sorry, yes, just keep it, you don't need to do that. So C squared in terms of A, yes, so in this case, yeah, so C is equal radical 4 pi A, and the square root of 4 is equal to 2, so C is equal to radical pi A. Yes, C is equal to radical pi A. Okay? Thank you for this. Okay. Question 3. Check this out. The arc length of a sector above is 4 pi. Okay? this figure is not drawn to scale. Usually that happens, okay, in the M1. So just it's like a representation for a figure. So we got here, as you can see, that's those are numbers, okay. A to C, this is the arc, and the radius is equal to 8, as you can see here. Fine. So the figure, okay, not drawn to scale. What is the angle measure of the sector ABC? So ABC, which means this part. Sorry, this part. A, B, and C. Fine. So what is the angle measure? Okay, if the arc length is given, which is 4 pi, okay, the arc length of the above is 4 pi. So I means 4 pi is equal, okay, theta over 360 times 2 pi, and the radius is 8. Okay, so in this case, I can replace the 360 with 2 pi because 360 in radian 2 pi. That works also. So, or I can just keep it as it is to keep it in the degree, theta over 360, no problem. So if I want to get theta as in radians, okay, I will put this 2 pi, but I want to get the theta in degrees, I just leave this in 360, and in M1 it's always degrees. Okay, so in this case, pi cancels the pi, so 4 is equal to theta over 360, and it's equal to times 16 over 4, we can say yes. So in this case, 4 over 16 is equal to theta over 360. Okay, over 4 over 4, 4. Okay, we can say now cross multiplication, theta is equal to 360 over 4, and theta in this case is equal to 90 degrees. As you can see, it's 90 degrees. Yes, check. It is 90 degrees. Yes. Fine. This is question 3. Let's go for question 4. So here, question 4. The circumference of the circle is x pi units, and the area of the circle is y pi square units. So if y is equal to 2x, what is the radius of the circle? The question, the circumference, which means 2 pi r, is equal to how much? X pi. And the area, which is y pi, yes, pi r square is equal to what? Y pi. Yes, y pi. Okay. So we have two equations. So pi cancels pi, means 2r is equal to x, and pi cancels pi, and y is equal r squared. Okay, what's the relation between x and y? Y is equal to 2x. Okay, excellent. So y is equal to 2x. I understand that. So in the place of y, I put r squared. And in the place of x, I put what? 2r. So r squared is equal to 4r. So let's say I'm solving an equation. So it's r squared minus 4r is equal to 0. So r is equal to r minus 4 is equal to 0. So r radius is equal to 0. That's not acceptable. And r is equal to 4. Yes. So if the r is 0, means it's a dot. Okay. In this case, the r is 4. And that's the radius, what we want. Okay. This is the end of question 4. Catch you in question 5. Okay. Question 5. I have this sector. Okay. I have this sector, which is AOC. Okay, I want the percentage of this sector from the whole circle. So if you remember the sector rule, okay, which is theta over 360 times pi r squared, and the area, which is pi r squared. Okay, so pi r squared cancels with pi r squared. So theta over 360, which represents what? The sector area. Theta over 360 represents what? The sector area. So, which I do now. What's the theta? Which is 47.3, as you can see here. And we can calculate now. Check this. So 47.3 over 360, of course the pi r squared cancels with pi r squared times 100 to turn it into percentage. The sector divided the area times 100 to get the percentage. So in this case I get 13.40%. Okay, this is the end of the circles. Always remember to know the rules, the circle rules, okay, pi r squared the area, 2 pi r the circumference, and the semicircle, which is pi r squared over 2, and think about, and you can send me a message, how can I calculate the circumference of a semicircle? Think about it, we can discuss that later. Bye-bye.